Hey class, it's Mr. Roberts at Shasta High School. Let's take a look at question 27 from chapter 10. It says solve each equation, explain or justify your steps for part B. So let's start with A. I'm going to rewrite this. It's going to be 2 times the quantity of x plus 1 plus 3 is equal to 3 times the quantity of x minus 1. So this is me kind of emulating, what you typically would do because you've got to copy the problem as it appears, especially if it's an equation, and then proceed from there. So I'm going to choose to use this distributed property twice on both the left-hand side and the right-hand side. So on the left-hand side, when I distribute this 2, this will become 2x plus 2, and then plus an additional 3, and that equals 3x minus 3. I can combine some like terms on the left-hand side, so 2x plus 5 is 3x minus 3. If I add 3 to both sides, this is 2x plus 8 is 3x, and if I take away 2 x's from both sides, I get that 8 is what x is. And then I just pause for a moment, and I'm just going to put a number 8 here and a number 8 here and ask myself, are these really the same? On the left-hand side, 8 and 1 is 9 times 2 is 9 times 2 is 18, 19, 20, 21. So on the one side I get 21. Is that the same on the other side? 8 minus 1 is 7. 7 times 3 is 21. So yeah, this totally checks. This is a solution because it is a value for the variable that makes both sides true. Okay, part B asks me to justify my steps. So the thing I want to do is just start with this statement. Look, I've got the absolute value of something is 10. Okay, I understand that there are two things that could be inside of the absolute value and produce an answer of 10, right? This thing inside is either 10, because the absolute value of 10 is 10, or this thing inside is negative 10, because the absolute value of negative 10 is 10. So these, right, looking inside, the thing inside the absolute value is either 10 or it's negative 10. So I write these two statements. I write, hey, 2x plus 1 could equal negative 10, or I'll write it down below a little bit. 2x plus 1 could equal positive 10. So those are the two things it could be, right? The 2x plus 1 is either negative 10 or it's positive 10. In the case that it's negative 10, that means that 2x is negative 11 and x is negative 11 halves. In the case that it was positive 10, that means that 2x is 9 and x would be 9 halves. And if I put both of those values in, right, into here, if I double negative 11 halves, that becomes negative 11. Negative 11 plus 1 is negative 10, and the absolute value of that's 10. So this value checks. If I double 9 halves, that becomes 9. So right, 2 times this x, right, 2 times this x is going to produce 9. 9 plus 1 is 10, and the absolute value of 10 is 10. So x is either negative 11 halves, or, this is the word or, x is positive 9 halves. All right, the final question, I actually have, I erased it, but it's sitting right here, is this. And it says, we're just focusing on this right now, it says, hey, solve for x. So here's the thing I want to point out, right? This is the absolute value of something is equal to a what? A negative number? That's some kind of magic, because remember, the absolute value tells me how far something is from zero. It doesn't have a sign to it. So there's no way that I could look at the absolute value of something being negative. So for C, I would have to say there's no solution. No solutions. And by the way, when they ask us in B to justify our steps, I would just point out that the 2x plus 1, right, looking inside that absolute value expression, that could either be negative 10 or positive 10. And for C, again, if you have the absolute value of something is equal to a negative number, I don't know, negative 12, or you have an absolute value is less than or equal to or just less than a negative number, less than negative 3, there's no way that an absolute value can be less than a negative number, right? So in both of these cases, right, an absolute value is equal to a negative number, or an absolute value is smaller than a negative number, we know that there's no solution.